Hello, grade 12 and 11 for that matter. We're doing this development exercise. Here is the question. You are given the figure below shows an incomplete front view and a top view of an intersection of three air conditioning pipes. Pipe A, B, and C. They are joined together. They are air conditioning pipes. Instruction: draw according to scale 1:1 and in first angle orthographic projection the following, the given views with complete interpenetration curves. These views given, which is the front, the top. Draw these views as they are, and then you show the curve of interpenetration, how this branch pipe penetrates this one and that one, penetrates up to that corner there, which is equal on both sides, also there and there. You have to show that also there. That's what is expected of you. Develop the development of the branch pipe marked A. There's a branch pipe that is marked A. This one will do the development of that. If you know how to redraw this, you can fast forward this video because I'm a very slow educator. Because I understand some learners, they find it very difficult to even redraw this. I also had the similar challenges when I started up, so I understand their situation. They may be in grade 12, but they will have challenges. Before I draw in a second, I'll start with the top view. Top view is an auxiliary view because you see it directly from the top. So this is the true diameter, the true shape here. So we will have true shape of this one because we're looking at it directly. Now I will diameter 52. I'll draw this circle which is radius 26. Start with that, but before I do anything, I'll start with my center line. Checking also that everything you are able to see from my camera. Arranging my camera. Center line is a long short line. That is center line. Okay, there we are. I have a center line. I want to draw it a little bit upwards so that I am able to do the development at the bottom one. There is my center. Now 52 millimeter diameter, that one. Fifty-two is 26. You must have a good quality compass. There we are. My ground line, and I project it to the top there. You draw these views simultaneously. There is my ground line. I draw them simultaneously. I project my top view, my front view, project my front view there. It will start here, down here. I want to start it here. The height of it is 68. 68 is the height. I will measure 68. Alright. Can fit into my paper. 68 is the 1, 2, 8 is the 68. Fortunately, I'm able to see my 68 there. There's my 68 there. Okay, what else is outside our scope? I have our 68. I'm adjusting my camera. There we are. 68. You will have 11 here. 11 and the 45 degrees. Let's measure 11. There is our 11. 11, 45 degrees 45 degrees I use my special set square here for 45 degrees. I can put it here, fine, yeah. Here is a set square, 45 degrees, just faintly. I'll draw it faintly. And perpendicularly at 90 degrees, I can draw it anywhere. I can draw it anywhere to get this 32 millimeter diameter. I can draw it anywhere because I've not been given that length, or either this length is not given to me. But when I make a straight line here, I can see that it is in line with that one there. But I don't want to take it for granted. I can at any given place make my 45 degrees there. 45 degree. That 45 can also use the very same set square. Can use the same set square anywhere here, just faintly anywhere here. This 32 is gonna be 16, 16. Take 16, 16. 16, 16 gives me 32. 16, 16, 16. There is my 16. Yeah, you can see it. 16, 16. Look at what I do here. I measure, that is 16. There we are, 16, 16. 16 on the other side is there. On this side, my center is there. Just to verify, I was right. Now, because it is 45 degrees, my center, there we are. I can do it like this. Center, that is my center. Try to draw it by yourself. Some of you might think it's easy, but when you do it, then it's then that you discover that there we are. Now, because it is in line with that line, I will just take it from there. From there, I know it ends there. It will end here. So now I am sure of my line, that my line is here. That's why I'm making it solid, completing all the other sides now that are not there. Come on. Completing that side and that side. Try to do it without watching me doing it. It will be nice. It will be interesting to see whether we will be able to redraw that. And then on this side, I must measure 14 so that I get that side, and then that is 40. I must measure 14. 14. There is my 14. 14 is there. Very faintly go up. Very faintly I go up. And then I may not know this distance. This distance has not been given to me. But I can assume also, if I'm not sure, whether with my t-square, once I do this, I can see that it's not even in line with what we have there. But by visually looking at it, I can see it is almost, these sides are almost equal. It's not given to me. I'm tracing it. I'm tracing it. If it is given, it's about 7.5 from here, 5, 6, 7.5, yeah, which means it is equidistant from here. That will be the center of everything. From the center of 68, I will measure, center of 68, I will measure 34. 34 from here to here, it will be 34. 34. 34, 34. What I do have there is 34. There is my 34 will be there. That will be my center here. From 34, This 40 will be 2020. 2020. 2020. 40 is 2020. Oh my God. That is my 2020. There we are. So now, almost done with redrawing. Even for redrawing the given, you are awarded marks. You've accumulated a lot of marks right now. I must tell you that now. That is the front. Now the top. The curve of interpenetration, I have not done it yet, but I'm drawing these views simultaneously, same time. Others views, I get it from the other. That one, that center line of mine, that is there, is my center. There is the other corner there. And then you have been told that this is 32. So anything that is round, from whatever view you are looking at it, is 32 there. Even from that side, you will see 32. From here, this is 15, 16, 16, that is 32. 16, 16, 32. Where is my ruler? There is my 16, 16. Good. 16, 16. 16. 16. It's my 32. My 32 will be, it will go right up onto the center there. Right up onto the center there. Look at what I do now. From there, I will make an arc over here. I'm making an arc somewhere. Even here, it's okay. Make an arc. Because it is at an angle, you don't see it exactly as it is. So I am making an arc. We make it a little bit darker so that you are able to see it. Even there is the same story. We make that very same arc also there. And then I will make 12 equal divisions. And then I'll make with a 30-60 degree set square. There we are. Right. There I've divided it. Then I move it across. There. 2, 3. 1, 2, 3. Make those divisions. Even there, remember, it is at 45 degrees angle. It is at 45 degrees angle there. As you see it there, so as you can see, 45. I'll maintain that 45 somewhere there, so that perpendicularly, you can see I have this line perpendicular. So I can also divide it using the very same set square that I have. I rest it on this 45 degree set square, on this 45 degree set square. There we are. It's there. It's there, and there we are. Okay, you've seen what I've done. It's just that, yeah, it's okay. And also dividing the other side now. Wait a minute. What is happening there? with my set square. I'm fiddling my set square around so that I'm able to get to the other side, this side, and let's do that, and that side. Then you drop it at an angle of 45 degrees. Even if I don't use the very same set square, this one also gives me 45 degrees, and then I will drop that. Now I'm concentrating on this side. I will come to this side over there. Concentrating on this side. Now, since I have done what I've done, this line there, these 3 points here from here, 1, 2, 3. Okay, cannot see it again. Here from the corner, 1, 2, 3. 1, 2, 3. Right, I drop them. 1, 2, 3, the center. Again, 1, 2, very faintly, 3 at the corner there. 3, I drop them. Now let's look at what we have done. From the center, that's the center, 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 right? Then we start counting from the center. It will be 1, 2, 3 with the center. 1, 2, 3 with the center. 1, 2, 3 with the center. 1, 2, 3 with that center. Voila. Then with a steady hand, free hand, you join that free hand. You don't want to have a shaky hand. You must practice your free hand drawing. Grade 10. Then you have that. So you have the true shape, how it looks like. Not the true shape, how it looks at from the top, this branch pipe. Now we come to that one. This branch pipe here, say it's 40 right round, it's 40, it's a round pipe. If it was a square, they would have told us it's a square. So these are 3 branch pipes. They will tell you that the other one is a square. So they did not say that. It simply means all of them are round pipes. So this one is also round, which means here is also 40. So we'll measure 20, 20, 20, 20. Baba. You must encourage young kids to do it. It is a nice subject. If it's not there in your school, talk to your parents, to talk to the SGP to introduce it. It's nice, it's nice. You don't work hard here, you just practice to relieve stress from other learning areas, accounting or maths and whatever. When you're tired doing those, keep yourself busy with this one. Even now, it's during lockdown, I'm not bored, just playing with this stuff, which is very nice, very nice, a very nice learning area, guys. I would love to see every learner doing this subject. Now, let's look at this one now. Even here, how does this penetrate that one? We will also like to make some divisions there, because the curve of interpenetration, you can see it here, but it cannot be transferred to the other side. Let us take it to the other side. Let's see how we do that. This is what I will do. What I will do there, one for this branch pipe, right? This is the very same branch pipe there. Same branch pipe Then you make the divisions. 1, 'Wait a minute. Where did I down here? Alright. Come down, boss. Come down. Play with your set squares till you get what you've been looking for, guys. From the corner, 1, 2, 3. It's the same story. I don't have to do all of them. Once I've got 2, it's fine. That side, but for the sake of that, okay. What I'm doing there. There we are. So it penetrates up to there at the top, and then there is that line. We have this one, that 1, 2, 3. This is in line with that, that is in line with that, that is in line with that. So I might as well take it from here. 1, 2, 3 up to there. 3. Remember, I'm looking at it from the top. From the top, this part is at the top. That one is at the center. In the middle, it's here. This part here is at the center. This one is at the top. This one is at the center. The one that is at the center, it is there. Start here. And then you start counting. 1, 2, 3 at the corner. 1, 2, 3 at the corner. Then you join free hand, steady hand. That is the curve of interpenetration. That is the curve of interpenetration. And then on the other side, we're doing the same thing again. From the corner, 1, 2, 3. 1, 2, 3. This will correspond with that first one there. The second one there. Second from the last. There we are. And there we are. We will have something like that. This part is the one that is there at the top. It is there. It is there. And then the middle part, this one is this one. It is there. The middle part. From the middle part, you go back. 1, 2, 3. This is what we have here. 1, 2, 3. You see, it's not a straight line. It's gonna curve a little bit there. There we have it. That will be the kind of a branch pipe you will have. So we have completed the curve of interpenetration there. Completed the top view. We've seen how it looks like from the top. This, remember this, it looks faint, it's constructed. That is constructed, it was not that faint. This is constructed, it's constructed. And the rest, those lines that go there, those are construction lines, they are very faint. And then the rest is solid, it's solid, it's solid. Even your circle here, it's solid. Now, we are asked to develop this branch pipe. Once we have to develop that branch pipe. When we develop, remember we use true lengths, the exact lengths. We use true lengths. When we use true lengths, since this diameter here, they told us diameter is 32. we just open it. It's round, we open it. It's round, we open it to make it straight. So we get a circumference. Circumference is equals to pi times diameter. Diameter is 32. Pi, there is pi. Okay, pi, you know I don't want to write all these figures there. Those are 2 minutes. There is a symbol for pi. Pi multiplied by diameter 32, it gives us 100. It gives us 100.53. Now, the surface area, it is 100.53. Let's hope you see it there. I will draw a line here. Very straight line. Straight line is drawn here. I'm trying to make a surface development somewhere. But now I'm just going to check with the whole length. We'll be using true length. I will explain that later. I'm just testing whether it will be enough on this space. I'm looking at the longest side. The longest side is this height. Let's check. The longest side is in this height. Remember, with me, I have a camera restriction. My camera is restricted. Yeah, I have that. Yeah, you'll be able to see, but I will keep on moving it up and down. Now, 100.53. Then I will measure 100.53. That is when I open it. When I open it, it will give me this length. 100. You can see that there is 100. I start here. 0. There is 100.5, which is 100 and a half. 100 and a half. 100 and a half. There is the full length. When it is opened, it is 100 and a half. Let me check. If I divide it by 12 equal pieces, 8.4, almost 8 and a half. Sometimes it will be difficult to do that, but I hope maybe in grade 10 they did show you how to divide a line segment into 12 equal parts. You just draw any angle there. You can draw any angle. Let me check there if you can see it. My main worry, I just want you to see what I'm doing. I draw it. Draw a line. Just a line. You draw a line, and then that line, I take my compass. I make 12 equal divisions on that line. I don't measure these divisions. I don't measure them. Just anything that will give me 12 divisions here. Make 12 divisions. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then from those divisions, I'm able to take my set square. My set square, 2 set squares. Remember in grade 10, you learned how you taught how to make two parallel lines. So the last line, I can take it, I can put my set square anyhow. 2 set squares, you see, both set squares. I hold both set squares. I align the top set square. I align the first line with the last line. The 12th line with the last line with the 100 and half. 100 and half. Yeah, which is 100.53. I aligned it with that. It has been aligned. Then I will slide the rest, so that will give me 12 equal divisions. I will slide this and it will give me 12 equal divisions. You don't want to spend too much time on these questions. If when you divide by a calculator, it gives you at least a number that you can be able to divide. Go for it, go for it, go for it, Baba. There's no time to waste. Okay, now I'm wasting time. I'm taking this line and I'm drawing another line that's parallel to that line. There we are. So I do have my 12 equal divisions, and then now I can project faintly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now, when we do this stuff, I've divided it into 12 equal parts. I've split open my circle now. It's straight 12 equal divisions. Now, what you want to do here, when you make a development, use true lengths. True lengths, how do you get to the true lengths? We're developing this branch pipe. Look at this line, these lines. They are not parallel to the ground line. On the other side, look at it. They are parallel to the ground line. Once we have these very same lines, they are also represented on the other side. Here they are parallel to the ground line, which means this tube here is parallel to the ground line, which means on the other side you are seeing the true length. If one side is parallel to the ground line on the other view, which means on the opposite view you are seeing the true length. So here we are seeing the true length. These lengths are true. This corner from there, these heights are the real heights. Because why? Here they are parallel to the ground line. They are deceptive to you. We're looking at it this way, parallel to the ground line. But from this end, you are seeing exactly the true length of it. Now, I will transfer the length. So when you open a branch pipe or any other piece of material that you have to develop, you open it where it's smaller, the smallest size. So that when they join it, the joint should be the smallest. They join it on the smaller side. Maybe for cost efficiency, the weld will have a smaller weld here. So you split open it there. Now let's do that. From that corner, we've got 12 corners there. One, we start here. We start here, we will end there. 1. From there, we start here. Starts there and it ends there. It will also end here. And then the second one, this one, the second one, there we go. It is the second one, the second one. Go to the third one. The second one. The third one is this one there. There is its true length. Third one. There is its true length. The third one there. And there. Because there's still another side. On the other side, the fourth one, therefore, is this one and the one behind it. This one, the fourth one. The fourth one is there and there. The fifth one, this one. This is the fifth one. The fifth one is there and there. The sixth one, this was the fifth. This one now is there and there. The last one, smaller. This one was kind of longer. It was a bit longer. Let's check. Yeah, it was here. It was a bit longer. It was here. Up there. It was longer than this one. This one is a bit short. Shorter. This is a bit shorter. Now you join, guys. Join freehand. Yeah. Because this one I will treat it as a small curve like that. You want to have a steady head, guys. That's what you want to have. There. Voila. That branch piece pipe then has been developed. This is a development of this branch pipe. I hope you have enjoyed it. Do it several times if you don't understand it, and then it will start being alive in your mind, and you start enjoying it. It looks like this at the end of the day. Guys, grade 12 and 11. Thank you. See you in the next one.